Hello, everybody. I will introduce our first speaker today. Professor Ronald Lee is a demographer and an economist. Since 1979, he has been at UC Berkeley, and he currently is a professor of the graduate school in demography and economics, and he is also the founding director of the Center of the Economics and Demography of Aging at Berkeley, and now is the associate director. And his current research focuses on the macroeconomic consequence of changing population age distribution and on intergenerational transfers and population aging. And for 18 years, he co-directed with Andrew Mason the National Transfers Account Project, which includes collaborating with research teams in more than 60 countries. And now he continues to work on modeling and forecasting demographic variables, including mortality, and on evolutionary biodemography, particularly the role of intergenerational transfer in life history theory. So welcome, Ron.
Thank you. Let me now try to get everything in order here. Okay, now, I'd like to adjust the view, but
I think it looks fine. Yeah, we can see.
Yeah, okay, I just wanted to get the pictures. Okay, anyway, we'll go with this. So, it's great to be back here. Talking to this group again, well, the changing group. I'm going to be talking about work that has now been published in PDR a couple of months ago. Andy Mason and I and 71 other members of the NTA network are co-authors of this paper. And okay, so I want to thank all of them and acknowledge them, particularly the 71 members without whom this project network wouldn't exist and work like this wouldn't exist. Now, causal analysis, usually based on some sort of natural experiment, has become increasingly popular in economics and in social science. And sometimes one gets the impression that it's the only kind of research that is viewed as giving any credible insight and understanding about social processes. Increasingly, it's used in demography, and I welcome and applaud that. But at the same time, demography has a great deal of other approaches to offer that also offer insights. And to my mind, I often find the, what should I say? I'm not sure I want to say simpler, but more transparently grounded work of demography more convincing than this other work. In any event, today, I'm going to use the NTA data to try to draw some lessons, some understanding about what the future may hold insofar as consequences of demographic change for the economies. And I'm going to be using I would say very simple methods. And you won't see a lot of equations, and I'm going to try to avoid them where they occur. So let's go. And for some reason, I can't. Okay, here we go. So the NTA project now has over 70 countries with research teams in them. All the darker gray areas on this map are members in a sense, or they have member teams. And then in addition, NTA accounts have been estimated for the orange countries. So for a total now of, I think, 99 countries. The most recent country to join was Georgia. And the light gray don't have direct NTA estimates now. But in a project led by Andy Mason, there's been a sort of an imputation of the most basic NTA H profiles to an additional 87 countries. And so there are age profiles for 186 countries now, and those are the raw material for what I will be presenting today. So NTA includes just many dozens of different variables, and here I'm just going to use the most basic, which are labor income and consumption. And I say the most basic, they're not actually so basic. NTA labor income is an average across all individuals at each age, males and females, and including zeros. And so it's wages and salaries plus fringe benefits, all before tax. And then it's also labor's share of self-employment income. And then it's also imputed value of unpaid family labor on farms and things like that. So we'll see that in a moment. And then the consumption data is based on private household consumption, which is usually reported at the household level. And then we have various procedures for allocating it to individuals in each household. And then in addition to the private household consumption expenditures, it includes public in-kind transfers, not cash transfers, but things like public education, publicly provided health care, or publicly provided long-term care, or prorated value of public goods. So that's the raw material, these age profiles, as we're about to see. So here we have age profiles. These are average. These are all taken from the 186 countries, and then those are grouped into high income countries, which are the light gray, and low income countries, which are the dark. And so you can see that in the high income countries, earnings starts at an older age because of higher educational enrollments, and it ends much earlier because of generous pension programs and so on. Now, to put these on the same graph, we have to standardize them. Otherwise, the level of that light profile would be, I don't know, 20 or 30 times higher than the gray one. So these are, each country's is standardized by dividing every value by the average of the values between age 30 and 49. And we do the same thing for consumption below. So here's the scale on the left, there's 1. Between 30 and 49, those ought to average out to 1. And these are just, here they're just simple unweighted averages. Now, this is consumption, and you see in the high income countries, consumption is much higher for children, relatively speaking, than in low. That's reflecting particularly investment in education, both public and private spending on education. And then you see, very striking, at older ages, consumption rises in the high income countries and it declines with age in the low income countries. So the point is, these age profiles have different shapes. Even when you average them over many dozens of countries, there are clear differences. And if we looked at individual countries, you'd see big differences. And those are all reflected in what I'm going to be reporting. Okay, so these are kind of pretty pictures, and they, I think, provocative. They lead you to think about many questions. But what can we do with them? What use can we make of them? Well, there are many, many possibilities. They've been used in many ways, including in quite complex economic modeling, general equilibrium dynamic models by some people, and many other things. But here I'm going to do simple things that sort of exploit the consequences of international heterogeneity in population size, in population growth rates, and age distribution on the one hand, and then the different shapes of these age profiles I just showed you, and in the productivity of labor in the different countries. Okay, and I'm going to report 6 different major findings. And this first one will get us going, but it's also the most complicated and will take a little while. But here I say the global GDP growth rate will drop by 1%. That is, in the next 40 years, it'll be about 1% lower than in the past 20, 40 years. And that's a big deal. Okay, we need some definitions. Think of country J, and we use UN population estimates and projections. Now, you saw those age profiles, so imagine an age profile like that for labor income in country J. We can multiply it by the population age distribution and then add across ages. Now, if we do this with the standardized labor income profile, like the one I showed you, we get what we call effective labor. And then if we do it we can do it for any year because we have population projections for other years. And then we do the same thing for consumption to get effective consumption. Now, we have GDP data for each country, so consider country J again. We can divide GDP in 2020, the most recent year, which we have, or the base year for this study for which we have GDP data. We divide it by this measure of effective labor, and that gives us this W sub Bj, which is productivity of labor in J. It's sort of average GDP produced by each unit of labor. Okay. Now, if we multiply this productivity measure times the labor, we get back the GDP in 2020. But if we do this for future population age distributions, we'll get back other GDPs, and their changes will reflect the sort of pure demographic impact on the economy. But of course, there are other things happening. There's continuing productivity growth, and if we want, we can incorporate that in these sort of pseudo projections as well, as we'll see in a sec. Okay, so here we have population growth rates. This is global from the United Nations, and a 25-year period, another 25-year period, and then a 20-year period for the most recent 20 years, and then we look at the next 40 years. So you can see the population growth rate has been declining steadily. And here we have the effective labor growth rate, aggregated up by adding all those countries and then calculating a growth rate. And you can see that the effective labor growth rate is somewhat different than the population growth rate. And in particular, for the first 25 years, it's rather slower. That means that the number of dependents is growing more rapidly than the number of workers, so the dependency rate is rising, or the support ratio is declining. And the same is true from 1975 to 2000. But when you look at the last 20 years, you see the labor force has been growing. I'm sorry, I said that wrong. 1975 to 2000, the labor force was growing much more rapidly than the population. And this is generating a so-called demographic dividend. It's a boost to per capita income growth because workers are growing faster than population, which is the denominator in those calculations. And that's also true in the last 20 years to a lesser extent. We have a kind of demographic dividend, but after 2020, for the next 40 years, that will no longer be the case. There's a slightly the opposite will be the case because of population aging and other things. Okay. Now here we have the growth of effective labor weighted by productivity in each country. And so this is again different than plain effective labor. And you can see it's growing much less rapidly initially, and same is true 1975 to 2000, and it continues to be true, and it continues to be true it will continue to be true in the next 40 years. Why is that? What's going on there? Well, most of the growth in L is taking place in low-income areas, particularly in sub-Saharan Africa. So when you weight L by productivity, you see that, that weighted sum grows much less rapidly because an incremental worker with very low productivity doesn't add much to the weighted labor supply. And that's going to continue to be true throughout this whole period. Now here we have GDP growth, and the first three entries in this column through 2020, those are just economic historical data in real terms, of course. And you can see it was much more rapid in 1950 to 75. Now, if we take the GDP growth rate and subtract the growth rate of weighted labor, then we get the productivity growth rate. Or did I say that? Did I say that wrong? Yeah, no, I said that wrong. Sorry, it should be the growth rate of GDP minus the growth rate of effective labor. Well, we'll come back to that. In any event, so here we have the productivity growth rate. And now, of course, we don't know what that will be for 2020 to 2060. And we're going to assume it's the same as it was in 2020. That is, the amount that each unit of labor is producing is rising by 2.4% per year, both in the last 20 years and by our assumption in the next 40 years. And that gives us a projected GDP growth rate of 2.65%. And you can see that's about a decline of 1% relative to the past 20 years. That's what I was referring to before. And now we can ask, well, what share of this is due to, what share of GDP growth is due to demographic growth? How much of this is driven by demographic change in population? How much was driven by it in the past and will be driven in the future? Well, it has varied. So in this last column, I'm just looking at the ratio of the growth rate of productivity weighted labor relative to the growth rate of GDP. It's just the ratio of growth rates. Usually not a good idea, but I think it's useful here. So you can see that in the 1975 to 2000 period, more than half of global GDP growth arose from demographic growth. Well, that declined to a third of it in the last 20 years, and it's going to drop to less than 10% in the next 40 years. So this leads us to conclude that the era of population-driven global economic growth is essentially over. Now, why does it drop so low? Well, again, it's dropping so low because of the geographic and economic location of where the growth in labor force is occurring. If we look at the growth rate of per capita GDP, it declines much less, as you can see here. That's because, well, the denominator is growing more slowly as well as the numerator. And if we were to look at individual countries instead of at this global picture, then I think in most cases we would see that per capita GDP is not growing more slowly at all, or in many cases that would be so. Some of this is, again, the shift of the center of gravity of economic growth towards the low-income areas. Okay, and it's sort of obvious, but population change is going to be driving large regional shifts in economic activity. The regional shifts going from the rich countries, East Asia, Europe, and North America towards sub-Saharan Africa. And those shifts are going to be greater than the population shifts. And we see that here in this table. Here we have the share of effective workers in millions in different regions of the world. And these regions of the world are classified by how slowly or rapidly their populations are growing. For example, this first group, they're growing, I think, less than 0.5% per year, or something like that. Well, so you see that the share has been declining steadily, and it'll decline over the next 40 years considerably. And we look at sub-Saharan Africa, and you see a big increase in that share. And if we look at the growth rate in effective workers will be going quite substantially negative in the next 40 years, whereas in sub-Saharan Africa, it's going to continue to be positive. And this leads to a shift in the regional location of economic activity. We could do something with maps and centers of gravity and so on, but haven't done that. Okay, third, prime age adults are being squeezed by population aging. That is the consumption of prime age adults. So we can see that in this chart. On the horizontal axis, we have, let's say, consumption by youth up to the age of 24 relative to the consumption of adults aged 25 to 64. And that's expressed as a percent. And then we have the same thing for consumption by elderly as a percent of prime age adults on the vertical. And these straight lines indicate averages. The dots are countries. And so, and the dark dots are countries with high old age dependency ratios. The light colored dots are countries with low old age dependency ratios. And so in this upper quadrant, you see mostly old countries located, and those are countries that have relatively high youth consumption and relatively high old age consumption. Or put differently, they have relatively low prime age adult consumption. That is, in these countries, which are the oldest countries, we also have the countries where the working age population has the lowest relative consumption compared to children and adults. Now, here you do have to worry about, is there anything causal here? Well, so many things are different in the old countries than in the young countries. I would hesitate to attribute anything causal here. But it's also true that this isn't really surprising so far as children go, because the reason countries are old is because parents in those countries have decided to have fewer children in order to be able to spend more on the education and human capital of each child. And so the fact that child consumption is relatively high in the old countries doesn't seem surprising at all. Why elder consumption has gone up so much is a different matter. And she probably couldn't do better than refer you to Sam Preston's presidential address in whatever that was, I don't remember, 86 or something. Okay. 4, age structure changes will boost. What was that?
Oh, I wanted to ask a question. Just about the previous graph.
Go back. Yeah.
So these are the schedules as observed kind of about now. Is that right?
That's right. Yeah.
Okay. So a lot of the generous to children and general to old age schedules were actually formed by policies when these countries were experiencing a demographic dividend. And they haven't changed their policies yet. I guess that could be a good forecast for the countries that are going to go through a demographic dividend in the next few decades, but it's not necessarily a forecast for how these countries are going to adapt to the constraints on them in the next decades.
Yep. An excellent point. Here we have Japan, about as far along as any country, and it seems solidly in the middle of that upper right quadrant. But yeah, I'd say also Japan hasn't yet really confronted the consequences of population aging, and it's only a little more than halfway through to where it's going to be by the end of the century. So it's got a lot of adjusting still to do. Yes, I mean, I agree. These age profiles are, well, here we're looking at them in the base year and not projecting them. But when we're doing projections, we're assuming the shapes remain exactly the same. And if we do a back projection to 1950, we're assuming the shape was the same then. And that's really not true. You have to take that with very large grains of salt and think hard about what changes you expect to see. But I'm going to talk a little bit more about that later. But yeah, so I don't think there are going to be big changes on the child side, but I expect there are going to be big changes on the old age consumption side, and even bigger changes on the old age labor side as we move forward in time. There better be, is all I can say. Okay. Age structure changes will boost per capita economic growth in low and lower middle income countries. That's demographic dividend, but it's going to slow it in high and upper middle income countries. That is population aging. Now, we measure the standard of living by aggregate consumption divided by effective consumers. So C is aggregate consumption, N is effective consumers. So it's better than just saying C over population, because N is taking into account the fact that children don't consume as much as prime age adults, and that the elderly in some countries consume more. And instead of taking everyone as a 1, you're weighting them according to actual observed consumption. Okay, now the ratio L to N, that is effective labor to effective consumption, is called the support ratio, which is something like a dependency, well, an inverse of a dependency ratio. It's actually close to the Shayanov ratio, if any of you have read the wonderful work of Shayanov back in the 1920s and 30s. And then the demographic dividend, or as we call it, the first demographic dividend, is the rate of change of the support ratio. Now, we're interested in this. This is consumption divided by effective consumers. That's our measure of standard of living. And that is identically equal to 1 minus S. S is the part of output that isn't consumed, times Y, which is GDP, total output per worker, times the number of workers per consumer. So, you know, this is just sort of identities arithmetic. But then if you calculate the growth rates of these things, proportional growth rates, then you get that the growth rate of the standard of living is going to depend on how these things change, but then it has an additive growth rate of the support ratio, which is the first dividend or an effective population aging. So this is what we're going to look at, this thing here. Okay, and what you see here for 2020, not doing any projection here, is that there's a negative demographic dividend that is mostly population aging, although it could also occur through increasing child dependency, which is perhaps what's going on in this part of Africa. I'm not entirely sure, but you can see it's basically north versus south that we're seeing here. And then in the south, we have positive demographic dividends, which are particularly, well, they're going to be very persistent in Africa. They're not particularly large in Africa. And they're also still occurring in Latin America, even though we have a number of countries below replacement fertility already there. Okay, and then here are, well, this is just showing the support ratio and the demographic dividends for different countries arrayed by group. I think I'll pass over this. Well, let me just say it can, that the dividend here, for example, for the upper middle income countries was contributing, even for these averaged over many, many countries, it's still contributing more than 1% per year to the growth rate in consumption per equivalent consumer. And in some cases, I think in China, it may be subtracting more than 1% in some coming years. So compared to productivity growth rate of maybe 6 or 8% that we've seen in India and China, this is small potatoes. But compared to a more stagnant economy, this is really quite potentially quite important. Okay, 5. Let's see, I'm running out of time. Let me just explain this concept of the old age gap. We know the old age dependency ratio, but that's sort of based on the 0 and 1 type categorization of population members. So here we use the old age gap, which is net consumption above age 65, that is consumption above age 65 minus labor income above 65, divided by total labor income. And so we can calculate that for each country, and we can aggregate that in different ways. Okay. Simple interpretation is that if you had a tax rate on labor income equal to the old age gap, it would raise just enough money to pay for the excess consumption of the elderly in that year. And so here we see an acceleration of aging taking place around 2020 or 2010, something like that, 2015. This is the old age gap, and you can see it rising quite dramatically, both in high income and upper middle income countries, but not changing much over this time frame in the lower middle income and low income countries. And in these countries down here, the lower middle income and lower income countries, the old age gap is only about half the old age dependency ratio. That's because the elderly are consuming less than other adults in these countries, and they're continuing to work. But in the high income countries, the old age gap is about 3/4 of the old age dependency ratio, because the elderly aren't working much and they're consuming more. Okay, and if you project these out to 2060, in Greece, that gap is over 100%. That is, you'd have to take all of labor income and then something more to be able to meet the future demands of the elderly, assuming no change in behavior between now and then. In Japan, it's going to rise to 76%. Yeah, there's going to be a lot of adjustment to happen of the sort that Josh was mentioning. Okay, and then the last thing, everything I've done so far is cross-sectional, even when they're projections. But here, I'm going to do something longitudinal, where take some year like 2020, we can look at each generation projected forward and see how much it's going to work, how much labor income it'll have in the future, and how much consumption it will have in the future, and what the difference is longitudinally projecting forward. And we can do that for for every age in the population, and then we can add those all up, and that gives us a sort of absolute, what we call the wealth gap, and then we can divide it by something else to sort of standardize it to the size of the economy. Okay, so this is what that looks like. This is expressed as a percent of current total labor income. And you can see, so for the rich country, high income countries, that's increasing relative to total labor income by about 150%. That is, it's going to be more than twice as big, 2.5 times as big by 2060. And it's already almost 10 times as big as current labor income. Upper middle income is absolutely lower, but it's increasing even more rapidly. And then here you see the other countries. So the rising wealth gap is an important factor here. And what is going to happen? Well, one possibility is that we're going to change those economic profiles, age profiles, by working longer, by perhaps having the elderly consume less relative to other adult ages less than they do now. And that will offset some of these problems. But otherwise, we can increase the amount of public transfer wealth. It's wealth in the sense that you can calculate a present value of the difference between what you're going to get back and what you pay in. Now, transfer wealth does not raise productivity. It's a burden on future generations. But on the other hand, it would likely reduce inequality for the elderly, depending on the nature of pension structures. Another possibility is that there's increased saving and asset accumulation. This has the advantage that it would bring beneficial macro benefits. It would raise productivity. It would not burden other generations, but it would probably go with increased inequality, almost certainly so, because we know most people don't save much in the economy as it is. And there's some possible problems with so-called secular stagnation, but because it's so late, I'm not going to say more about that. But different countries and regions of the world so far have taken different approaches to dealing with these issues. One last thing, as I should say, is we've kind of grouped together here public and private transfers, because they're also familial transfers in many countries, particularly in East Asia, to support the elderly. But they have the same problems as public transfers and additional ones as well. Okay, thank you very much.